Hello, welcome all. Today we are going to talk about open source databases and ARM. So we'll try to understand what is the status of different open source databases on ARM. My name is Krunal Bauskar and I have been driving this DB on ARM initiative. That's quick intro about me. I've been working in MySQL space for quite some time now. In past, I've worked with Oracle, Percona, Yahoo Labs, and Teradata. Currently, I'm working with Huawei as part of the open source DB group, where we are trying to drive the DB on ARM initiative, trying to make most of the open source databases and their ecosystem work on ARM, and not only work, but also optimal on ARM. uh, that's where I write my blogs. You can follow and get more details about it, and that's my tweet handle if you would like to get more updates about what we have been doing on day-to-day basis. So with that, let's talk about today's agenda. So first we will try to understand why ARM, and then we will try to understand why run databases on ARM, and then we will jump to our main topic of state of open source databases on ARM, and we'll end it with some direction about future work. We all understand ARM has been pretty popular, and in fact it is catching steam in this recent time. So if you look at the market share, ARM has already been very much dominating in the mobile processing market with 90% market share. In on the network equipment front, it already holds 32% market share, which is supposed to double 6 to 65% in upcoming few years. It is already a market leader when it comes to IoT devices. With cars, automobiles, especially with self-driving car, ARM is set to also get a pretty good market share there. 75% of the existing market share is owned by ARM on the cars and automobiles front. What is something new and which is of more interest to us is use of ARM in data centers, and especially for high performance computing. As of now, it is estimated that ARM will capture 25% of the cloud or data center share. In fact, if you have read the report recently in 2020, the most booted machine on Amazon EC2 or AWS was ARM based machines. So that said, it is very much clear now that ARM is going to be the next generation and future of computing. So with that note, let's understand why we should consider running databases on ARM. So databases are compute intensive. That means they need a lot of compute power, and ARM actually help you offer the same thing at lesser cost. So that means your databases can make use of this compute power and produce better throughput. We will see with some real life example where we have seen an improvement in range of 50 to 100%. ARM, of course, not is limited to standalone setup, but the cost performance advantage it offer can also help you save a big time on when you talk about a cluster or HA kind of setup in a range of 30 to 50%. That's the estimated is. ARM, so databases rely on a lot of external libraries, maybe compression, maybe networking. Now operating systems offer ports for ARM, and along with the needed all the supporting libraries. So porting things on ARM is simpler, and of course porting is simpler. The tuning was challenging, but now there are enough amount of resources available in public forum that will help you to port easily your databases or your ecosystem tools on ARM. A full stack ecosystem can be enabled on ARM with all softwares, surrounding softwares of the ecosystems. So we'll see some example of that too. So with that, let's jump to the state of open source databases on ARM. So we tried considering some of the most popular databases from all categories. Now, in fact, the list is not exhaustive. There would be more databases that you could add and which are running on ARM, but we are just consider some representative database. So we have relational database, we have NoSQL database, we have OLAP database. Most of these databases are already supported on ARM directly from the respective vendor. Some of them are in process of getting supported. Some of them are in advanced stage where they are running in form of CI/CD. So let's get started. So whenever a user moves from one setup to other setup, user do care about following four aspects, right? Whether he or she is going to lose on feature set by moving from one setup to the new setup. What about the performance? Is he going to lose on performance, or it would be better, it would be worse, it would be on par? On ecosystem front too, user do want to make sure that all the ecosystem component that he is used to in the previous ecosystem or setup are already available in the new setup. And being open source database, community support is also important. So these four aspects we will be using to evaluate different open source databases. So let's start with MySQL. So MySQL have been releasing packages for ARM for quite some time now. So if you have been tracking 8.x, starting 8.x, they have been releasing packages for ARM. And the packages, since they are directly coming from upstream, they are complete in sense, even the extended features, whether it's been log replication or group replications, are also inherent part of the server, and they are also supported on ARM. MySQL scales well on ARM. We are of course going to see that through some performance number. As far as ecosystem is concerned, MySQL already have been offering server, but not only server, the other supporting components which MySQL releases, like shell, router, connectors, are also offered on ARM. That helps mark the completeness of the ecosystem. MySQL enjoy a pretty good community support with a lot of active developers who have already submitted patches and these developers come from different organizations. Then there are blog articles around MySQL on ARM. There are bug fixes or bugs that has been reported, and of course MySQL has addressed almost all of these bugs with the same priority like its other counterpart. So if you would like to follow more about it, you can always join the MySQL on ARM channel, which is available on community Slack. MySQL currently offered packages for CentOS, REHL, and Oracle Linux. That's where some improvement is needed, especially on the Debian front. If the MySQL can start offering it on Debian front, that would be really helpful. And Docker images are also missing, so getting it images for Docker would be really helpful too. Now, if we talk about it from an ecosystem perspective, what we tried to do was here we tried identifying from every category we can find at least one or two open source products which are which are available on ARM. So and we see if we can actually get the picture complete, right? So on server front, MySQL of course is available on ARM. HA solution, so inherent bin log replication or group replications in form of InnoDB cluster is available on ARM. On backup, Percona extra backup is community evaluated. You can run it on ARM. Load balancer, router, and proxy SQL both have been available directly from the official repo. PMM, Percona, and community evaluated. It works on ARM. Connectors again directly from MySQL. The packages are available, and toolkits. It's mainly Perl scripts, majority of them. So they work on ARM. And shell, again there are packages on ARM. And of course, if you are used to run things in Docker or Kubernetes kind of environment, then both of these environment are available on ARM. Docker images for MySQL, though are missing, you can always build it. And eventually, I am sure MySQL will also start releasing respective Docker images. So in short, a user planning to run a full stack ecosystem of MySQL on ARM, it's completely possible, and that too using all open source tools. If you talk about performance, so we have used the latest version of MySQL 8.0.24 and uniform sysbench workload. And here we have used a cost performance model where we kept cost constant and allow resources to vary. ARM being cheaper got more resources, and MySQL was able to make a optimal use of these resources and help us produce better throughput. So for same cost, MySQL has produced almost 2x throughputs in some of the cases, and in fact it scaled better than its counterpart. So the message is, for same cost you could get better TPS or throughput. The other way to look at it is, what if we keep the compute constant and let's let the cost vary. So ARM being 50% cheaper, you get 50% cheaper, or you save on cost, and you give the same compute resources to both of these variant. And here, as you could see, ARM is able to scale, on par, or in fact better than its counterpart in some cases. So the message here is pretty simple: for lesser costs, okay, so because you are saving on the cost, you are getting on par or better TPS. So whether you use model 1 or you use model 2, in both cases ARM is advantageous. So basically running MySQL on ARM is always advantageous. Oracle, excuse me, Oracle has been investing time and efforts, to take on the patches from community. In fact, with 8.x, there has been pretty revived interest in fixing NUMA scalability issues, which threaded locks, scalable lossless mutexes, and that is completely helping ARM, because ARM is all about more cores, and more cores get you more NUMA nodes. With 8.0.24, all atomics were moved to use C++ atomics. So that actually has helped again on ARM, because as part of the exercise, the memory order were made optimal rather than the default memory order. MySQL 8.0.24 also introduced support for GCC 10, and GCC 10 actually has an support intrinsic atomic, which actually further enhances the performance of ARM atomics. So overall, I think MySQL on ARM is pretty in a good shape for user to start trying, even probably considering it in production and given the cost advantage ARM provides. MariaDB on ARM. So MariaDB has been one of the forerunner, and it has, of course, official packages for it on ARM. They have already accepted a lot of patches. In fact, in 10.6, a few patches they accepted that help it scale further to 1.6 million, especially on NUMA, 4 NUMA nodes. So NUMA scalability itself is a big challenge. We'll talk about it probably later. There have been pretty active efforts to make sure that the other ecosystem components that MariaDB has are also could be made available, at least from community side, and support from MariaDB are available on ARM. And of course, there is a pretty good and strong community. Bugs has been reported by users, and MariaDB has fixed it. In fact, that is a good sign that users have been trying, and that's why they are hitting the bugs. Distro support is also better. We have, MariaDB has been supporting distros for CentOS, REHL, Ubuntu, and Debian. And also MariaDB evaluate ARM as part of their CI/CD. So that is one of the test cases has to pass on ARM before the things or patches could be folded to the mainline trunk. From ecosystem perspective, again, we tried considering all the open source component here, and as we say, MariaDB server or the inherent binlog or basically multi-master, which is implemented using Galera cluster, all of them are offered directly as part of the main MariaDB package. Backup is also part of the package. As far as load balancer is concerned, you can use ProxySQL. MaxScale is not yet fully ported, but I am sure the community efforts are there going on to get it ported. PMM again works on ARM. Connectors are there, and DB tools, whether it's Toolkit, Ghost, or DB deployer, and environmental tools are always there. So even a user thinking to run or boot a full stack ecosystem using MariaDB, open source tool of MariaDB, it's possible. Performance wise, we have used this 10.6 which is work in progress, and again with cost performance model where ARM get more resources, MariaDB is able to make effective use of these extra resources and scale better than its counterpart. So again, the same cost, more TPS. And if you keep the compute constant, then you could again observe the same pattern that either you will get on par performance or better performance in some cases. So for lesser cost, which is like almost 50% lesser cost, you are getting same throughput like the existing counterpart. And this is interesting. So, in recent 10.6, NUMA scalability issues were fixed, wherein the QPS for point select touched 1.6 million and read only touched 1.1 million. NUMA scalability has its own challenges, but just to give you a fair idea, around 40% improvement was observed, and things were not scaling well when we moved from 2 NUMA to 4 NUMA, but with the applied patches, it started to scale well. So MariaDB has been accepting patches for ARM for quite some time, and they have been also doing their own efforts to getting evaluate some of those things. In fact, with 10.6, it's really good to see some of the NUMA scalability challenges being solved. MariaDB also, as I said, have been evaluating all their features against ARM, especially the performance critical features that they are developing. They make sure that they are evaluated against ARM. Ecosystem and distro support is also being further widened, and we know users has been also exploring not only the standalone MariaDB server but MariaDB cluster on ARM, which again is being evaluated by community. Percona on ARM. So Percona don't have official packages on ARM, but most of the things have been inherited from upstream. So most of the core feature works on ARM, and it has, in fact, it has been pretty widely evaluated by a lot of community members, and it works completely fine on ARM. Of course, it scale better on ARM. Again, upstream inherited. Percona enjoys a pretty good ecosystem. They have tools from all categories, whether it's backup, monitoring, and all toolkits and all. So, of course, most of these things have been already evaluated or tried on ARM by some Percona engineer and also by community. So all of them works very good on ARM, and Percona enjoy pretty good community support too. If I recall it correctly, Percona was first to get tried on ARM, especially on those kind of PI4 kind of board or so, and that way there are a lot of users who probably would be interested in trying or seeing Percona on ARM. So the flexibility, openness, and community support which Percona enjoy will help do more adoption of Percona on ARM, and we would expect Percona to start releasing in near future all the packages for all its products on ARM. As far as ecosystem is concerned, again, as we say, some of these are community evaluated, some are directly offered. So server, Percona server, HA solution, you have Binlog or PXE for multi-master backup. We have Percona extra backup, load balancer, we have ProxySQL, monitoring PMM connectors, toolkits, and MySQL shell. So overall, if a user planning to work or get a complete full stack ecosystem putted on ARM, and is it possible? And yes, it is possible through all again open source product, and so that is a wonderful thing to get everything working, a full stack ecosystem working on ARM. And again, no surprises here since it is mostly upstream inherited. So we could see that the performance wise, Percona is able to, or Percona on ARM is able to beat its counterpart, whether it's the cost performance model or compute constant model. So Percona server beyond the core feature has a lot of add-on features. Now, of course, not all of these have been tested by community. So some of them, I think porting wise, they will work. There's no issues with it. I think the testing is what is needed, and probably further optimizations if there is a need for it. As far as ecosystem is considered, there are a lot of ecosystem tools. So, getting it working on ARM official packages would really help. And Percona can, of course, work on NUMA specific improvement, because Percona server is all about better performance, and they could start working and fix some of these NUMA scalability issues, and probably that would help them perform even further better than the upstream. PostgreSQL on ARM. So Postgres also have official packages on ARM. They do enjoy pretty good community support. They have already accepted a lot of community patches. Postgres ecosystem is pretty mixed. A lot of vendors have respective packages from that perspective. After pgsql community started releasing packages, most of the vendors also started releasing their own tools or packages or supporting tools on ARM. So that way the ecosystem is expanding. We will see some example. It is almost in a pretty good shape, but it is further expanding because there's so many tools to consider. pgsql, of course, there is a pretty good active community. There is a revived interest inside the community, especially after Apple launched ARM, and it was made it easy for end user to start trying it in a desktop format. pgsql also offered packages for on CentOS, Ubuntu, Debian, and of course, I think the Debian you can always try it with other distro. It should just compile because the compatibility is still there. As far as ecosystem is concerned, again, we have considered the same thing, all open source component. So server directly coming from Postgres. Most of these tools are directly coming from the respective vendors. Postgres, SQL, then HA solution, Rep Manager, PG Pool 2, there are packages, PG Backrest for backup, there are packages, load balancer, we have PG Bouncer, audit plugin is there, PMM again community evaluated. A lot of connectors are there. DB tool front, we have loaders and GIS. So overall, most of the packages, most of the tools are available on ARM, and pretty possible that the tool which you are using, if it is not in this list, of course there are so many tools which probably available, packages are available on ARM. So a user would like to willing to run complete full stack ecosystem of pgsql on ARM, and it is possible. On performance front, we have used PG Bench, and we have two lines here. In fact, one is of course the x86, other is ARM, and the other third line is about ARM patch. So there was a patch that was submitted. As you could see, with ARM is able to scale better than x86, and in fact with higher scalability across x86. There is a small drop that is observed in some case, and that also get fixed through the patch, and that's why we thought sharing that line of patch is important. The patch is not yet accepted. It is stuck into the community process, evaluation process, but it is about switching the TAS to CAS, which is a very common issue if you have been working on ARM, or in fact even with general other flavors of operating architectures. So the idea again is coming up to be the same. For same cost, you can get more or better TPS. And we also evaluated it with Sysbench, while PG Bench is the standard for pgsql, but we thought we'll also evaluate it with Sysbench. And here you could see that in some cases, pgsql on ARM is able to beat its counterpart. For some cases, we could see that the patch version help get closer to its counterpart, but there is still a gap that needs to be covered. And I would say that there is a still good scope of improvement, so that that particular gap could be catched up. So that is another good thing that as a community we could look into and start contributing patches around the things. So pgsql has been, again, as I said, accepting patches that help them release the packages back in 2020 pretty fast. On optimization front, they still continue, there are still few things which could be looked into. Ecosystem, again, it's pretty good responses there. In fact, with rising popularity of running pgsql on cloud, having everything tuned for ARM will help it further adoption. So overall, pgsql also is in pretty good shape when it comes to ARM. ClickHouse. So ClickHouse is from OLAP category. So of course it works on ARM. There are no official packages, but it's officially supported. Documentation clearly says so, that you are supposed to build it directly online. It scale on par. Ecosystem also, most of the tools are available. There is growing ecosystem support. So there is growing community support. Sorry, and but of course there is scope to further improve. What is interesting is, with this being an OLAP database, it is more relying on it can actually harvest the power of parallel cores, and ARM is all about less powerful but more number of cores. And so that way ClickHouse on ARM is a perfect fit, or basically ARM is the optimal choice to run ClickHouse. Here too, on ecosystem front, you can say that you can run all, you can find one or two components from all category that are available on ARM. Server, of course, is there. Cluster is inherent. Backup, you can look for. Load balancer, proxy SQL is supported. Prometheus on monitoring front, connectors and tools. So if a user willing to boot up a full stack ClickHouse ecosystem on ARM, and user can do that with all open source components. Performance wise, ARM is slightly better when it comes to loading. We have used the star schema, which is standard for OLAP kind of evaluation. So ARM is slightly better with respect to performance. That is a time to load, by the way. And a query, there is a mixed response. Some cases ARM score, some cases the counterpart scored. But not to forget here that you are using an ARM machine which is coming at 35 to 40% lesser cost. So if you sacrifice, probably you get the same cost, you will get more cores of ARM. And as I say, ClickHouse will be able to make efficient use of this extra cores and further scale it. So for comparison purpose, we have used the same machine, and you could see that the cost of ARM machine is around 35 to 40% less. And this is a statement from ClickHouse documentation where it says that instead of having powerful cores and lesser core count, get us less powerful core and more core counts. And I think that is the best thing why ARM is the best suit for ClickHouse. Other thing is ClickHouse use vector based query executions, and ARM has pretty good support for SIMD and Neon through its Neon instruction set. So that way also ARM is amazingly, I would say, optimal fit for running ClickHouse or OLAP kind of databases. MongoDB, it's from NoSQL category. So MongoDB have official packages on ARM. So since it's official packages, most of the functionality are supported, and no problems with it, including the replications and sharding and all. MongoDB also scale better on ARM. We'll see some performance number. Most of the ecosystem tools are directly inherently offered by the MongoDB itself. So all of them, since it's officially supported, these tools are also available on ARM. There is a pretty good community. Of course, most of the articles I've seen are around use of MongoDB on a smaller kits like PI4 or so. I think in the future we will see MongoDB being tried on data center for running the real application workload or so. And of course, there is a promising improvement. I think very importantly, it actually makes some part of the picture complete, because you can have now heterogeneous database ecosystem moved onto ARM. As far as ecosystems is concerned, as I said, majority of the tools are directly coming from the MongoDB. So you have server, you have HA solutions in form of sharding or replications, backup, dump and restore, or you can use Percona backup, which makes it easier. Again, inherently uses dump and restore. Then load balancer, we have MongoS smart drivers. Then there's a free monitoring which is being offered, or you can use PMM connectors are there. DB tool, you can use Mongo database tool, Mongo shell. Mongo Compass is also, I tried, I was able to get it compiled. I faced some Node.js issue. I'm not an expert in Node.js, so I couldn't finish investigating or troubleshooting it. But I think with fair some amount of more investigation, we will be able to get it. So the idea is pretty clear that if a user is planning to run a MongoDB ecosystem on ARM, then it is again possible using all open source components. Performance wise, we have used the Yahoo Cloud Serving benchmark. Here again, we have mixed results. ARM is lags in some cases, especially in load and read only workloads. In read write workload, ARM is able to scale better. Not to forget, again, here we are looking at ARM machine which is coming at lesser cost, 35 to 40% lesser cost, and of course it is less powerful that way, and saving on the cost also. So probably if you get a cost constant, then you will I'm sure ARM will be able to be on par or better than its counterpart. So MongoDB usage is more from sharding perspective for web scale kind of data. From that perspective, the ARM best suits it, because ARM is about the cost effectiveness that ARM has to offer, make it an optimal choice. MongoDB, of course, has support for optimizations. There is few more possibility to further improve it. Missing ecosystem components could be further looked into, and support could be added. Now let's talk about the future work. So a lot of things to be done. NUMA bottleneck, beyond basic server optimization, looking at NUMA bottleneck, and not only the server ecosystem component needs to be tuned. Ecosystem coverage needs to be improved. Distro coverage, or whether adding it a Docker images, needs to be further looked into. Scenario-based testing, and making a poster complete, adding more databases on air to the ARM. So that these are few directions. So I would say if you are interested, you are following this, then you can, always, if you are willing to contribute, you can connect back to us. That's the way you can connect back to us, and would be helpful, contributing to community and making this complete so-called DB on ARM ecosystem more complete, more optimal. And again, thanks all organizers and sponsors for making this possible, and providing the opportunity to share our ideas. Thank you so much.